The region between two concentric spheres of radii b and a respectively has a volume charge density rho equals to a by r, where a is a constant, r is the distance from the center. At the center of the sphere is a point charge q. The value of a is such that the electric field in the region between the sphere will be constant. So we want electric field in this region to be constant here. So let us consider this sphere. You can see this is a cavity, and at the center I am putting a charge q here, which is given in the question, and rho is a variable here in this region. Rho is varying, so we can denote this rho here as rho equals to a by r. Okay, now I will try to find the value of electric field in this region, okay, at any general position r here from here to here, and I will equate it to constant value. I will say that the electric field that is there, that will be constant. Okay, so this is the reason I'm talking about. Okay, I'm just solving it by taking a general cases. Okay, we want our electric field to be constant in this region. Okay, so we can write rho equals to a by r, and in the last I will give you one trick also which will help you to solve the question in 1 minute also. So rho is a by r. So if I write electric field at this position, so I need to know how much charge it is enclosing. So the total charge it encloses, the charge that is q at the center, plus the charge in this shaded region that shading it right now, this one, this shaded region. But we cannot directly use the formula rho into the volume of this shaded area, shaded portion, because the problem will be that rho is not constant, rho is variable. So we will go by that basic approach. We will take a strip of thickness dr, radius r. We will calculate charge on it and we will integrate it from here to here. Okay, so let us calculate dq in shaded, dq in strip, or dq on strip. If I calculate, then this is going to become 4 pi r square dr times rho. So this is 4 pi, rho value is basically a by r. So we will get here 4 pi r dr times a. So this is our dq. So dq q in shaded portion, if I write, then that is basically 4 pi a integration of r dr, and we are going from a to some general radius r. So in this case q will become how much here? Q will become 4 pi a, that is q enclosed in the shaded portion. I am writing q enclosed 4 pi a and this is r square by 2 a to 1. So this is 4 pi a and this is r square minus a square by 2. So that is 2 pi a r square minus a square. So this is the charge in the shaded portion. Now electric field at r, if I write E at r, I will be writing that E at r will be kq by r square plus kq enclosed by r square, and it is saying that the electric field is constant there. So it is not a function of r, that we need to keep in mind. So here if we substitute the value, this is going to become kq by r square plus k, that is 2 pi a, and this is r square minus a square by r square. So for ER to be constant, I can say for ER to be constant, it should be independent of R. Yes or no? It should be independent of R. It should be independent of R. So if we simplify it here, E at R, we get here KQ by R square plus K into 2 pi A, K into 2 pi A minus K into 2 pi A, and this is A square by R square. So I will equate this term and this term to 0 value, because they are saying that electric field has to be constant in this region, so it should be independent of R. So I will say that KQ by R square minus K times 2 pi A square by R square, this should be equals to 0. Yes, we have to equate it. This value should be equated to how much? 0, because these are the variable part. Okay, so this has to be 0 because it has to be independent of R. So I will say that if Q comes out to be here as here, if we solve it, KQ by R square, this should be equals to K times 2 pi A square by R square. R square will cancel, K and K will cancel. So we get here, we have to calculate the value of A. So we get Q equals to 2 pi A times A square. So we will get here A equals to Q by 2 pi times A square. So that will be our answer here. A equals to Q by 2 pi A square. So option 1. So I hope you have understood it. Again, I am just telling you the important point here. The important point is in this region we will find the electric field as a function of R, and because it is said that electric field is constant in this region, so it should be independent of R. It should be independent of R. We calculated the value here and then we equated it to this one, 0. This R term, whichever the variable term we have here, we have equated it to 0.